Our first segment is with Jeff and Lisa Turner of Laughingstock Farms in Freeport. The Turners use 100% used cooking oil to heat their greenhouses.
Well, the basis of this project is we needed to find an economical and environmentally friendly way to heat the greenhouses. We have about 17,000 square feet of greenhouses now, and energy consumption is the second biggest cost for the business after labor. Besides that, we're a certified organic farm, and you know, would have just liked to be able to find a way that we could not use as much petroleum oil, especially with the global things going the way that they are. So about 4 years ago, we did some research and we came up with a way to burn vegetable oil for energy. The vegetable oil has just a little bit less energy content per gallon than number 2 heating oil, and it's available and it's around. So when we looked at Freeport, we found that we had a lot of it here in town. These drums that you see behind us represent about 4,000 gallons of oil that we have saved up for this winter. We right now are running 1 oil burner on this vegetable oil, and we are about to increase that to 2. We've ordered another one and it should be here this next week. It'll take me a couple of weeks to get it installed. So how do we get the oil? We basically made arrangements with local restaurants who up until now have had to pay a rendering company to collect the used oil. Generally, it's not viewed as something that they want to see in municipal waste, or certainly can't dump it down the drain. So, so disposal of this stuff is a cost to the local restaurants. So we wrote a grant to the Maine Department of Agriculture. We were ultimately accepted into the grant program, and the premise of the grant was to do a environmentally and economically beneficial heating system in a way that would provide economic benefit not only to our farm but also to the restaurants in town. And the restaurants normally had to pay to get rid of the stuff. We've basically offered to take it for free because it has an energy value to us. So the goal was to provide a benefit to us and provide a benefit to the restaurants. And during the first year of operation, our estimates are that we saved about $8,000 of disposal costs for the local restaurants, and we saved about $9,000 of energy cost for us. So it works. It has proven pretty successful so far. We're now in the second year. We've made some improvements, and it's working even better this year than last. We were filtering through a very fine filter screen last year, and we did away with that because it was very labor intensive. We came up with a way of heating a tank so that all of the solids settle out, and you'll see that when we do the tour of the facility. But all the solids and water, everything, just settle to the bottom, so we can get clean oil now without having to filter it, which is a huge benefit over last year. So what we do is we go make arrangements with the local restaurant, and we say we'd like to get your oil, and what we would like to do is set 55-gallon drums at your restaurant. When you change your fryer, have you dump your oil into the 55-gallon drums, and then once a week I'll come around and check the drums, and when they're full I'll pick them up and I'll leave you new empties. And so that's what we do. Every Sunday morning I travel around to all the restaurants, I check all their drums, and whenever one is full I pick up that drum, I leave them another new empty, and I bring the drums back to the farm, and we store them until we're ready to use them. And this is how we pick them up. This winch and this clamping mechanism is what we use to pick up the drums. So I'll show you how this works. I push the button. It lifts up the drum, and then it's on a pivot on the pedestal here. So I get around the other side of the drum and just swing the drum over into the trailer, and then I tie the drum off to the sides of the trailer so it won't slide around. And when I have 4 full drums in the trailer, I bring them back to the farm. And then when we're back at the farm, with the drum on the trailer, I use the same clamp with this chain and the forks on the front of the tractor that I'll show you in a second to lift the drums off the trailer and set them on pallets, and then we can move them very easily with the tractor. So come on back around here. We are a small farm, so we don't just grow in greenhouses. We also grow on about 12 acres of land outside in the summertime. So we do have farm equipment, which makes it really nice for handling this stuff. This tractor with this set of material handling forks will very easily handle 1,000 pounds of oil, or it'll actually handle 3 55-gallon drums, but 2 of them fit comfortably on a pallet, so that's what we do. So that's how we actually move them around. We store them here all together in one place, and then once a week my son and I will take the drums 2 at a time down and put them in the greenhouse to warm them up, clean them, and transfer them to the oil storage tank where they'll get burned. So what happens is the drums are stored outside in the wintertime, so they're frozen solid, because obviously we're doing this during the heating season. So they come in cold. The first thing we do is we set them on this box. Now this box is essentially a glorified radiant floor heating system. So inside the box is concrete with that PEX tubing that's heated with hot water from this system. So we're kind of starting with something I haven't explained yet, but we'll get there. So the drums sit on this thing, and we cover them with this insulation, and over the period of a day or 2 they warm up and they melt. And when they melt and get warm enough, the water and the solid food bits all kind of float to the bottom of the drum. And that's what we want. We want them to get to the point where there's as much clean oil on the top of the drum as possible. So then we take this hose and wand, and we pump from the 55-gallon drums over into the strain tanks. So that pumps into this, which is a tank that has this perforated trough in it. It's just perforated steel. The oil gets pumped over into here, and all of the big particles get stuck in the trough, and all of the small particles and the water and everything go down through. Now this tank is, again, it's heated with that PEX tubing with 200-degree water, and then covered with this insulation. And what happens in here is the temperature of the oil gets raised to, I think, somewhere between 120 and 140 degrees. And when that happens, even more of the solids settle down to the bottom. So all of the water, all of the flour, all of the breadcrumbs, all of the stuff that basically we don't want in the oil burner go to the bottom. So then we let that sit for a while, and then we take this pan and we set the pan down under the bottom of this drum. Now there's a valve right on the very bottom of the invert of this drum. So all of the water is heavier than oil, so it goes to the bottom. So we open up this valve very slightly, and you can see water coming out of that. And that's what will happen. The water will separate from the oil at a higher temperature. We collect all this water, and obviously there's water and there's kind of digested food in it, so it's pretty disgusting, but it's worth it to get the energy from the oil. So the water comes out, and we pour that water into these jugs. And that water gets saved up, and then in the summertime we collect between 200 and 400 cubic yards of horse and cow manure every summer that we make compost for the farm. And so all of this water and all of this leftover food bits gets added back into the compost. After the water's all settled off the bottom and we've got it collected, we'll be left with oil that looks about like this. it's pretty clean at this point. That clean oil is then pumped from this tank over into this tank. And we've got more of that PEX tubing on this tank just to keep the oil warm, because we run the greenhouse at 45 degrees and the oil will solidify at 45 degrees. So we have to keep everything at least a little bit warm. And then after that, when the space thermostat calls for heat, says it's too cold in here, the oil burner, or the unit heater will come on, the fan will blow and the pump will run, and it'll pump hot water and air through that thing and heat up the space. That lowers the temperature of the water in the loop. These are the two water pipes. And as the temperature of the water goes down, it'll get to a point where it turns on the burner. When the burner comes on, there's an air compressor and an oil pump over here. They both turn on, and the oil gets fed through this burner into the nozzles. The nozzle looks like this. So the oil goes in the hole in the bottom, the air goes through these little channels here, and it all gets mixed together. In this little spinner. That little spinner will take the compressed air, spin it around, the oil comes through the hole in the very middle. It mixes it all together and spits it out the hole in the end of this nozzle and creates a very, very fine fog. That fog is enough to allow the oil to ignite and burn very completely. So that's the gist of it. When we did this project, we did a lot of research. I'm an engineer and I've done a lot of research into biodiesel. We looked into the whole concept of making biodiesel. We also looked into a number of other kinds of energy solutions. And ultimately, the more we researched biodiesel, the more we came to the conclusion that if we could find a way to burn the oil without having to use the hazardous materials to transesterify it into biodiesel, we would be ahead of the game. Well, we came across a study that was done by the National Renewable Energy Lab that showed that it takes about 1.2 units of energy to make a unit of petroleum medium distillate energy. In other words, for every gallon of heating oil you use, you're really using 2.2 gallons of heating oil. That's the best argument in the world for conservation. When you save a gallon, you're really saving 2.2. Well, it takes about 1.24 units of energy to make a unit of biodiesel energy. So when you burn a gallon of biodiesel, you're really burning a gallon of biodiesel and 1.24 gallons of petroleum energy. Well, when we looked at that data closely, we saw that on the oil side, all of the energy required to get the oil to the plant just before they make it into biodiesel is about 0.16 units of energy. So when we looked at that, we said 0.16 units of energy for the oil compared to 1.2 units of energy for the biodiesel. If we can figure out a way to burn the oil directly, that's 750% more energy efficient than making biodiesel from this resource. And that's not to say that biodiesel is a bad thing. Biodiesel is a very, very good thing. We're real strong supporters of biodiesel. But the premise of our work has been to find ways that we can help local small agriculture be more successful. And from our perspective, the best way to do that is to work on a local community basis. So one of the premises of the grant was that we would work with local restaurants and we would use this oil locally. So we're not transporting it long distances. We're providing economic benefit to other small businesses in town. We're providing all of the same air emissions benefits that biodiesel produces, and we're doing it in a way that also doesn't require any hazardous materials or any of the other issues with biodiesel. So from my perspective, where biodiesel is important is on a national basis, where we look at the fact that the federal government is still paying farmers to keep acreage out of production, and they're also subsidizing the soy farming industry for other purposes. From our perspective, rather than pay a farmer to keep an acre out of production, let's use that same money to subsidize the production of soy oil for making biodiesel. And that biodiesel can then be used in diesel engines for transportation purposes. But on a local level, let's use the vegetable oil that we have at home in the most energy efficient way that we possibly can, which is for heating oil purposes. And so that's what we've tried to do. And so far it's been very successful, not only for our farm, but also for the town of Freeport. I guess the last thing that is important to understand about this is just one very small possible solution. It's a solution that we developed for an agricultural use, but really everything that we've done here would apply to any small business that has a space heating requirement, particularly like warehouse type space heating requirements. Obviously our focus is on greenhouses, and our focus is on greenhouses of this scale and bigger, but an awful lot of interest in this system has come from people with smaller greenhouses. And so one of the things that I'm working on now is to try and figure out ways that we can adapt this a little bit better to smaller greenhouse operations, and that I think will make it more adaptable for other small business types of applications. It's, like I said, it's one small solution to a big energy problem, but I don't believe we're going to come up with any one big solution. I think it's going to take lots of little solutions, and I think this is one.